The purpose of this video is to graphically represent data using Google Sheets. So I already have a blank Google Sheets document open. So you can get to that by going to the Google Classroom and opening up Sheets from there. If one's already linked as part of an assignment, you can go to your Google Drive and open it up, or go to sheets.google.com and you can create a new Google Sheet there. Once you have that set up, you're going to have a blank sheet. At that point, you can take data that you've collected from somewhere else, and start adding it to your blank sheet. So right now, the relationship I'm going to be looking at is the relationship between mass and velocity. So column A is going to represent the masses that I collected. Mass, and we measure that in kilograms. Just to make sure the data is nice and organized, put the variable at the top of each column and include the unit of measure. That unit of measure, by default, ends up in parentheses, just so it's very clear to see what we're measuring and what unit we're measuring it in. So that's column 1. My column 2 is going to be velocity, measured in meters per second. Once I have those headers set up, I can start adding my data. Now, I'm typing in 1.0, 2.0, but Google Sheets is just assuming I want it to the nearest whole number. I don't. I want it to have exactly the number of data points and points past the decimal specifically that I recorded using my equipment. So that way I have the correct number of significant figures in my data table. So to fix that, I've highlighted all of the boxes I might be using for that data. And then going up to our top, where right here, we have different ways that we can represent our data. One of the things that Google is doing is it's changing the number of decimal places that I have. So I'm just increasing it by 1 because I have enough precision to go 1 place past the decimal. And then I'm just going to continue with that for all of my data. I'll do the same thing with my velocity. And because it's not ending with 0.0, it's just going to record the number as I intend it to. But just to make sure that that stays the same way, I am forcing it to say it's going to be exactly 1 place past the decimal. Then I'll finish typing in the data that I have. Once I have done that, I want to create a graph that represents this data. So I am going to select all of the data that I have. I'm going to go up to the top where it says Insert, and then down here to where it says Chart. Google is going to look at the data and make a recommendation about what type of chart you're looking for. Because this data was collected in a lab, it makes sense to represent it with a scatter plot, but sometimes it might represent it with other chart types. My recommendation is when it opens up, make sure that if it's not suggested as a scatter chart, you just scroll down and select the type of chart you're looking for. So scatter chart would be, well, about halfway down. But this is set up. Once you have that there, it actually does have this chart editor on the right-hand side. You can set it up, so changing the chart type. If for some reason your X and the Y axes need to be swapped, you can just click on those drop downs, those 3 dots there, and it should allow us to change our data for which data point ends up where. We can switch the rows and the columns. If we don't want it to be having it as numerical values, you can treat it as text. Lots of different features that we can have. But some of the main things I want to focus on is in our customization. Chart style, it's useful if you want to change the colors, but not as important as, say, the chart and axis titles. One of the nice things about Google that Excel doesn't necessarily default to is if we have variables and units at the top of our data set, Google Sheets does actually populate our axis labels and propose a decent title. You can retype it if you want. You can change the font, bolding, colors, whatever you want. But make sure that we have a title and axis labels for our charts. We can identify and change what the data series looks like. If you have multiple data series, you can just select this drop-down menu to select whichever ones you have. Particularly useful if you have lots of different data occupying the same graph. But underneath this section, the series, this is what is perhaps the most important, the trend line. when you click on that, it's going to force a linear regression there, trying to best fit your data. But if you have an exponential, polynomial, logarithmic, power series, or moving average as your relationship, you can select that as well. But I'd always recommend just looking to see if the linear makes the most sense, first of all. One other thing we want to do with that is label it. The label is where we can use an equation. The Google Sheets program will do a mathematical linear regression to determine what the slope is going to be based off of the line of best fit for the data, as well as the y-intercept. This right here is a perfectly accurate mathematical representation of the relationship between these two variables. But one of the reasons why we graph data in a science classroom is to talk about how that math relates to science and physical phenomena. That's why we need to focus on what variable would be the y in that y equals mx plus b model, what variable would be the x, what is the physical meaning of the slope and the y-intercept. Those are things that we can focus on after we have graphed our data, which was the purpose of this video. Now, there's a couple other things that we could do with these Google Sheets before we wrap up the video. Right now, because my data starts off relatively close to 0, that's why I have 0, 0 as the actual origin of my graph. But Google might not necessarily focus on that range. It might not start from 0. It might have a break in the graph. If you would like to fix that, go over to where it says horizontal or vertical axis, depending on which one needs to be modified. Select the drop-down menu and the minimum value. If you want to force it to go through 0, you can force it to go through 0, at least for the scaling here. You can do the same thing for the y-axis as well. And one really cool thing about Google Sheets is once you have a graph there, this little drop-down menu that's on the top right of your graph, you can actually download it as either a PDF document or a PNG image. That will allow you to insert this graph as an actual image in a lab report or some other format.